Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 8th grade topic, dividing exponents. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see here today, or even your own homework, you can always put it in the comment box below, or visit me on my Facebook page at Tutor Me Senpai and tell me all about it there. Today's video will have 2 parts, so leave a like, smash the subscribe, and let's get started. Now, dividing exponents is going to be very similar to multiplying exponents. So if you're pretty confident in multiplying exponents and you know how to do that, you have that under your belt, I don't think dividing your exponents is going to be much more complicated. However, if you struggle with multiplying exponents or even need a refresher, no worries. I have a video that will break down how to multiply exponents right up here. You can check that out at any point in time and then come back to this one just so you know how to multiply and divide. So just like multiplying your exponents, dividing your exponents has a certain criteria you have to hit in order to move forward to the next step. So if you recall, multiplying exponents required you to have the same base. So let's say we have something like this, 3 to the 5th times 2 to the 7th. Our base, once again, was this bigger number, while our exponents were these smaller numbers up top. In order for us to multiply this, we said we need the same base. This is going to be true for division as well. The first thing you have to do when you're dividing exponents, well, at the very least, when you're dividing the expressions, remember we did multiply expressions, we're going to be dividing the expressions. And you can't go any further than this if you do not have the same base. And sometimes you will see that you may not have the same base, but you can transform one base into the other, just like we did in our multiplication video. However, if you can't even do that, if your bases are not going to be able to be one common number, then you can't move any further than this. You are stuck here. This is pretty much all you're going to get. Let's say instead you have something like this, 2 to the 8th divided by 2 to the 6th. Now, in this case, we have 2 as our common base. They're both the same, so we can move on to the next step. And just like we did for multiplication, something is going to happen across the tops. In this case, it's going to be the opposite of what happens when you multiply. So division is going to be the opposite of multiplication. And when we multiply our expressions, we add it across the top. So what's the opposite of addition? Subtraction. You're going to be actually subtracting across the top. So you can do a small little subtraction sign there to signify what you're going to be doing across the tops. So when you have something like this, where you have the same bases, you can go on to the next step, which is subtracting across the top. So you're going to have that same base and the resulting number you get from subtracting across the top. It doesn't really matter what your base is. So let's say you had a variable base raised to the exponent 32. And you want to divide by the same variable, which is raised to the exponent of 20. We can do the same thing, check to make sure we have the same bases, and then subtract across the top, resulting in this. 32 minus 20 gives us 12, so 12 is our resulting exponent. So it doesn't matter if you have a constant or a variable, it's going to work the same way. As long as they're the same, you can move to the next step. If this was a y instead of having that x, you cannot do this equation. This is not the same base. Therefore, you cannot move to the next step. Now, it's very important that you realize order matters for division and subtraction. Now, order didn't really matter for multiplication or addition because whether you do, let's say, A times B or B times A, it's the same thing. Likewise, A plus B and B plus A, the same thing. It doesn't really matter the order in which you do this. So technically, if you had some multiplication and you're adding across the tops, it doesn't really matter which way you place them. However, division and subtraction are very different. We know that 5 divided by 2 is not the same as 2 divided by 5. Likewise, 5 minus 2 is not the same as 2 minus 5. So this means our order is going to be very important. You can have division of your expressions. Let's say 2 to the third divided by 2 to the fifth. And this is not going to be the same as 2 to the fifth divided by 2 cubed. And that's because whenever you're going to be dividing and subtracting across the tops, you're going to get whatever that results in. This first number minus the second number. You have to go this first number minus the second number because this is your numerator and this is your denominator, right? We're writing it like this, but technically it's going to be your numerator first and your denominator second. You have to make sure you don't get those confused. Likewise, there you go. You see, these are not the same. Now you may be looking at, what is this negative exponent? If you have no idea what a negative exponent is, no worries. I actually have a video on that one as well. You can check up here at your leisure whenever you have some time, and you understand what it means to have negative exponents. But notice, -2 we know is not the same as a +2. So order matters. Make sure that you're dividing in the correct way, that you're subtracting what you need. Don't just try to get the higher number and subtract the lower number. It's not going to work. Your numerator has to be first, your denominator has to be second, and you're going to be subtracting in that fashion. Now, I didn't really talk about why it works for the multiplication video, but for multiplication, it's a little bit more obvious. So if you have, let's say, let me not use variables. Let's do some actual numbers. Let's say you have 2 cubed times 2 squared. Now we know that 2 is going to give us that 2 cubed. And we know that 2 is going to give us that 2 squared. And technically everything is multiplied, so you can rewrite it all like this, and you just count up how many you have. All you're really doing, if you write it out like this, is adding across the tops once again, but you're just counting. Since everything has an exponent of 1, you're just counting. So it kind of makes more sense why you would just add across the top without having to really explain too much. But dividing may be a little bit more, let's say, unclear why you're just subtracting across the tops. And I think it becomes a little bit more clear when you write it in this fashion. So we have, let's say, 2 to the fifth over 2 cubed. When you write it in this fashion, you'll see why it makes a little bit more sense that you're going to be subtracting across the tops. Now remember, this is your numerator, this is your denominator. What we're going to be doing is subtracting whatever's in the denominator from your numerator. So this should be this once we're finished. But I want you to write out what 2 to the fifth means, as well as what 2 cubed means. This is 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. Now you can rewrite this. Let's say you want to break this up into individual fractions. So we have 2 over 2. So we take care of one pair here, times 2 over 2, take care of another pair, times 2 over 2, take care of another pair. And we have no more 2's in the denominator to pair up with the numerator, so we do something like this. Now what's 2 divided by 2? Well, this is going to be 1, this is going to be 1, and that's going to be 1. So technically, we have 1 here, 1 here, 1 here, times 2 times 2. And you see, 1 times 1 times 1 gives us 1. 2 times 2 gives us a 2 squared. We have what we have here. Everything matches up. That's because you're pairing these off, and when you pair them off, they become 1. You can also say that we're canceling these out if you're more familiar with that terminology. But in either case, these things become 1. And what's left over is your final result. The same thing can be true if you were to flip this. So let's say 2 cubed over 2 to the fifth. We said that this is going to be 2 to the negative 2. Now we don't necessarily know what negative exponents are, at least for this video, but I'm going to pretty much show you what it really means. this is 1 over 2 squared. And that's because if you write it out, 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2, what do you get? Remember, these are going to cancel out or pretty much turn into 1 when we break everything out, and we're left with what in the numerator? Well, it makes more sense if I do something like this. We're going to write it out and break it up once again, just so you can see. And you'll see, if this is not super clear, why you have a 1 in your numerator and you have the 2's in your denominator. So these become 1, right? Those all become 1, and you're multiplying all of those, which gives you 1, and you're left with 1/2 times 1/2, which means you have 1 over 2 squared. This is why it's important that we subtract across the tops. Because we're effectively pairing them off and then reducing down to 1, we're losing copies of whatever the base is. Thus, we are supposed to have a smaller exponent because there are less bases being joined together to build up a new one. Previously, we had 5 bases in the bottom and 3 in the top. Now we're only left with 2 in the bottom. So subtraction. We need to subtract because we're going to be pairing 1 for 1, top and bottom, until there are none left. Once you run out, whether in the top or the bottom, you're going to take whatever's left, and that creates your new exponent for your base. So I hope you are following today's videos, and I hope you see that dividing your exponents is going to be very similar to multiplying your exponents. Make sure you have the same bases, and instead of adding across the tops, you're subtracting across the tops. However, if you have any questions about what we saw today or even on homework, remember you can always put in the comment box below or visit me on my Facebook page at TutorMeSenpai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe, and while you're at it, share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Senpai.